So here's the theorem here again. The only time you'll be asked to show this is when being asked to find exact values, and it will usually involve situations with your special angle. So keep that in mind as well. So for this here, you know, if we're asked to find the exact values of these things. Now, I haven't done any work. I haven't raised, you know, that complex number, negative square root 2 over 2 minus square root 2 over 2i to any other powers beforehand. And even if it were 5, you know, I don't need to, I mean, that doesn't have a whole lot of factors. So I'm just going to first convert the number into polar form. So z equals negative square root 2 over 2 minus square root 2 over 2i. That's the same thing as me having negative 1 times square root 2 over 2 plus square root 2 over 2, which means that z is going to be negative 1 times the quantity cosine of pi over 4 plus I times the sine of pi over 4. If I want to now raise this to the 5th power, I'm going to take negative 1 to the 5th power, and I'm going to multiply the two angles I have in there by 5 and get 5 pi over 4 for the two angles. And now I'm going to reevaluate. Negative 1 to the 5th power is negative 1. The cosine of 5 pi over 4 is negative square root 2 over 2. The sine of 5 pi over 4 is negative square root 2 over 2. But I'm multiplying through by negative 1, which gives me square root 2 over 2 plus square root 2 over 2i. So that would be the final answer for that. The more you save, the more time, the higher the exponent gets. Here, square root 3 over 2 plus 1/2 I. Again, I'm going to focus on z being the complex number itself. So z is going to be square root 3 over 2 plus 1/2 I. I'm going to actually the modulus for that is 1. So I look at square root 3 over 2 and 1/2 and say, is there any particular angle that if I take the cosine of it, I get square root 3 over 2. If I take the sine of it, I get 1/2. And the answer is yes, it's pi over 6. So z ends up being 1 times the cosine of pi over 6 plus I times the sine of pi over 6. If I raise this to the 7th power, I'm going to have 1 to the 7th power times the quantity of cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. And since 7 pi over 6 is based off of one of our special angles, I should be able to find the exact value. The cosine of 7 pi over 6 would give me a negative square root 3 over 2. The sine of 7 pi over 6 would give me a negative 1/2. And therefore, that's what the final answer will be. I'm going to have a negative square root 3 over 2 minus 1/2 I.